Welcome back CarTech Zone. Today we're diving deep into one of the most exciting developments in aviation, electric airplanes. In 2026, electric aviation has finally started to move from concept to reality, and there's a lot to unpack, from performance figures to cost comparisons, real airline commitments, and what it means for future travel. If you're into cutting-edge tech and transportation, stick around because this is going to be a full breakdown. Let's start with why electric planes matter. For decades we've watched cars go electric. We've seen Tesla, Rivian, Lucid, and legacy automakers electrify their lineups. Now the same shift is beginning in the skies. Aviation is one of the hardest sectors to decarbonize. Jet fuel is energy dense, aviation regulations are strict, and weight is the enemy. But engineers and companies have been grinding on solutions for years, and in 2026 we're finally seeing real electric aircraft in service, test flights, and commercial orders. Most people imagine small drones or two-seat trainers when they think of electric planes, and that is where electric propulsion truly started. But the industry has scaled rapidly. There are now aircraft with 4 to 6 seats, short regional commuter planes, hybrid electric prototypes, and even plans for 19-seat electric short-haul airliners. So let's talk about performance first. Electric aviation performance is fundamentally different from traditional piston or jet engines. Electric motors deliver full torque instantly, they have fewer moving parts, and they're far quieter. And that matters. Quieter aircraft mean less noise pollution near airports and takeoff zones. One of the most talked about electric aircraft in 2026 is the Alice E Cargo X by Aviation, a 9-seat electric commuter designed for short hops. This plane has a claimed cruise speed around 220 miles per hour and a range of roughly 440 nautical miles on a full battery pack. That's not jet-like range, but it's enough for many regional routes in the U.S., think Boston to Philadelphia, or San Diego to San Francisco. Performance metrics like climb rate, cruise speed, and range are improving faster than many analysts predicted. Electric motors are lighter than equivalent piston engines, and battery technology, while still the limiting factor, has improved energy density by about 25% over what we had just 5 years ago. That means longer flights and higher efficiency. But batteries are still heavier than jet fuel for the same energy content. That's the trade-off we're dealing with right now. For example, take the Heart Aerospace ES-30, a 30-seat regional aircraft that's hybrid electric. It uses electric propulsion for takeoff and climbing, and a small jet turbine kicks in for cruising to extend range. The S-30 can seat 25 to 30 passengers and fly about 200 nautical miles on electric plus turbine support. It's a transitional technology, not fully electric, but dramatically more efficient than conventional turboprops. Range limitations are where electric airplanes bump up against physics. Battery energy density isn't on par with aviation fuel yet. In practical terms, that means most fully electric passenger aircraft in 2026 are limited to short regional routes. But here's the twist: most air travel within the United States is short haul. Over 50% of all domestic flights are under 500 miles. That's exactly where electric aircraft can be competitive. Now let's talk about speed. Electric aircraft generally don't go supersonic yet. That's decades off, but cruising speeds are impressive for the class. Many are touching 180 to 240 miles per hour. That rivals smaller turboprops and is perfectly adequate on commuter legs. For cities that are 2 to 4 hours apart by car, these planes could cut travel times dramatically without the noise and emissions of traditional aircraft. Speaking of noise, one of the biggest benefits of electric aviation is how quiet these planes are. Electric motors generate a soft whir instead of loud piston or turbine noise. When you're on approach to land or taking off near a city, the difference is really noticeable. Communities around airports are paying attention. Quieter aircraft could help reduce noise complaints and open up new short-haul routes that were previously impractical. Let's break down prices. Electric airplanes are expensive to develop. There's no two ways around it, but per flight they can be cheaper to operate. The cost of electricity per mile is lower than aviation fuel, and electric motors have fewer parts that need maintenance. So while upfront purchase prices or lease costs might be high, the operating savings over time can be significant. For example, a fully electric commuter like the Aviation Alice has a projected list price in the range of $4 to $5 million. Compare that to a new Cessna Caravan, a traditional single-engine turboprop, which can be $2 to $3 million depending on options. Yes, the electric plane sticker price is higher, but over 5 to 10 years the savings on fuel and engine maintenance narrow that gap. Many operators run cost models that show break-even in 6 to 8 years based on fuel savings alone. Hybrid electric aircraft like the ES-30 are more expensive still, often in the $6 to $9 million range, because you're essentially buying both electric systems and a backup turbine. But the hybrid approach buys extended range and reliability while we continue to improve battery tech. Battery replacement cost is another factor. Just like electric cars, batteries have a lifespan. Aviation standards are even stricter, and replacement cycles are factored into operating budgets. But battery costs have dropped significantly over the past decade, and major OEMs are confident that by 2030 the economics will tilt heavily in favor of electric propulsion for short routes. We need to talk about safety. Aviation regulators like the FAA in the United States and EASA in Europe are notoriously cautious, and that's a good thing. Electric propulsion introduces new failure modes, thermal management challenges, and power electronics that have to be proven safe. But several electric aircraft have already completed rigorous flight testing and achieved certification milestones. The enthusiasm from regulators is higher than at any point in aviation history. Battery safety receives special attention. Electric aircraft use redundant battery packs and integrated thermal monitoring to prevent incidents. Engineers learned a lot from electric cars and adapted those lessons for flight. Thermal runaway is a big concern, and aircraft designers put multiple layers of containment and safety protocols in place. The level of engineering and certification scrutiny is extremely high, because lives depend on it. Now let's talk real airline interest. Several regional carriers in the US and abroad have placed letters of intent or deposits for electric and hybrid aircraft. Alaska Airlines has been vocal about exploring electric solutions for short routes in Alaska where distances are short and fuel costs are high. Other commuter operators in the Midwest and Northeast see potential economic and environmental advantages. One airline executive said publicly that electric aircraft won't replace jets on long-haul flights, but they will be ideal for feeder routes, the flights that bring passengers into major hubs from smaller cities. That's huge. If an airline can fill a 9-seat electric aircraft for low-cost flights between regional airports and then connect passengers to larger flights, the entire travel chain becomes more efficient. Charging infrastructure is a piece of the puzzle. Electric aircraft need high-power charging at airports. Think of it like giant EV chargers at terminals. Major airports are beginning to test these systems. At smaller regional airports, investments are happening faster because the scale is smaller and the payoff is more immediate. Airports in Arizona, Texas, Florida, and the Pacific Northwest are all piloting electric plane charging stations. A key concern is turnaround time. How quickly can an aircraft recharge between flights? Fast charging systems are necessary to keep schedules tight. Some designs allow for battery swapping. Take off the used battery pack and put in a fresh one, similar to strategies that were proposed for electric cars. That can speed up operations but requires infrastructure investment. Let's talk environmental impact. Electric planes don't burn jet fuel, so emissions at the point of use are zero. That's attractive for climate goals, especially for short flights that are heavy polluters when using conventional engines. The true environmental benefit depends on how the electricity is generated. If it comes from renewable sources like wind or solar, then emissions are dramatically lower. If it's from fossil fuels, the benefit shrinks. Still, electric propulsion is cleaner and quieter, and that matters for communities and climate targets. People often ask, will electric planes replace commercial jets? The honest answer in 2026 is, not yet. Electric propulsion is excellent for short regional routes, training aircraft, air taxis, and potentially cargo services. For transcontinental and international flights, we still rely on conventional jet engines, and likely will for at least another decade. But this technology is evolving fast. Emerging battery tech, solid-state cells, and lighter energy storage materials could push ranges further, and hybrid designs will bridge the gap. Some researchers are also exploring hydrogen fuel cells paired with electric motors for longer range without carbon emissions. That's a different architecture than batteries alone, and it's gaining attention in Europe and Asia as well. So what does this mean for you as a traveler? In the next few years, you might book a regional flight that is fully electric. It might cost less than a traditional flight. It will likely be quieter, and you might not feel the typical engine rumble. Airports will have charging stations instead of fuel trucks for some flights, and the environmental footprint of shorter flights will shrink. For pilots, electric aircraft are simpler to operate in some ways. Fewer systems to manage, instant torque, and predictable performance. Pilot training will evolve, and new certifications will become common as electric aircraft enter service. For aviation enthusiasts and tech lovers, this is an incredible time. The industry is undergoing change not seen since the introduction of jet engines in the 1950s. Innovation cycles are compressing, and companies that can solve the range, weight, and safety challenges will lead the next era of flight. Before we wrap up, let's talk about cost to consumers. Ticket pricing for electric flights is still evolving. Because operating costs can be lower, some regional operators plan to offer competitive fares, sometimes undercutting traditional short-haul flights. That could make flying more accessible for short trips and reduce reliance on car travel or long drives. But remember, early adoption always comes with higher costs until scale kicks in. As more electric planes are built, and the supply chain for batteries and motors grows, prices will come down. Airlines are banking on economies of scale, just like what happened with electric cars. The bottom line in 2026 is this: electric planes are real, they are flying, they are being certified, and they're about to enter commercial service in meaningful numbers. They won't replace jets for long flights yet, but they will change regional travel, lower noise and emissions, and open new possibilities for how we think about short-distance air journeys. If you're excited about innovation, this is a moment to watch closely. Electric aviation could reshape travel in ways we're only beginning to imagine. Thanks for watching CarTech Zone. If you found this video useful, hit that like button, subscribe, and let us know in the comments, what electric aircraft are you most excited about? Battery, hybrid, hydrogen, or something else? We'll catch you in the next one.